All right, the last of our trigonometric graphs, cotangent. So it's a lot like tangent. It's kind of tangent flipped over and shifted, but you'll see. So recall, cotangent of x is just cosine over sine. So he has all the opposite problems that tangent does. If sine equals 0, can't divide by 0, cotangent is undefined. And we've seen that happens if we graph sine really quickly. That happens at all the pi's. So that's at x equals n pi, where n is an integer. And if cosine equals 0, I was supposed to say if sine equals 0. If cosine equals 0, cotangent also equals 0. Because 0 divided by not 0 would be 0. Where does cosine equal 0? That's 2 pi, pi over 2, and 3 pi over 2. Right here and here. At the n, at x equals n pi over 2, where n is odd. The odd pi over 2's. Okay, so the basic graph of cotangent looks a lot like tangent, only now all of my asymptotes are at the pi's. Including 0, that's 0 pi. And all of my crossings will be at the odd pi over 2's. 1 pi over 2, 3 pi over 2, 5 pi over 2, and including the negatives. Negative 3 pi over 2. And remember, tangent, if I were graphing tangent, we would have a graph that kind of looks like this. Cotangent looks like that, but flipped over. It goes down instead of up. So we just keep repeating all this. This is supposed to be curvy. Let me try to draw one section that's nice and pretty. There we go. Like that. So it kind of looks like x cubed flipped over. Like that. So the domain. Remember, anytime we're talking about a function, first thing we want to say is, were we even allowed to use this function? What numbers am I allowed to plug in? The domain, the set of all allowed inputs. I'm allowed to plug in all real numbers, except those places here, the pi's. Because then we would be trying to divide by 0, and we can't divide by 0. And the range, just like tangent, this guy goes all the way down and all the way up. We use all possible y values, negative infinity to infinity. Okay, so that's the basic graph of cotangent. What if we shift it around? What if we throw in some numbers? So let's do one. Let's sketch. I don't know. Y equals 7. Cotangent of 4x minus pi over 2. Okay, just like with tangent, we don't really have an amplitude. What I call the amplitude is this height right here that would be at pi over 4, which is 1. Halfway between the asymptote and the intercept, that's the amplitude, how tall this spot right there is. So I'm going to put amplitude here in quotes, And that's still absolute value of A, in this case, 7. Period. We should write that up here. The period of regular old cotangent, without any shifts or anything, just like his buddy tangent, is pi. Sine, cosine, secant, and cosecant are all 2 pi. Tangent and cotangent are pi. And you just got to memorize that. So now that I've changed it, instead of just having x there, I have 4x. My new period will be the old period over b, which in this case is 4. My phase shift, negative c over b. Opposite of negative pi over 2 is positive pi over 2. Over 4, that's pi over 8. And again, I'm never going to give you a vertical shift. On a cotangent, these graphs are ugly enough as it is, but we could have maybe like a +3 out here, and then that would shift the whole thing up 3. But we're not going to. Okay, start and end. Different from everybody else. Sine, cosine, secant, and cosecant. It's always inside equals 0, inside equals 2 pi. For tangent, it's negative pi over 2 and pi over 2. For cotangent, we got something different again. Inside equals 0 and inside equals pi. We're finding out where these 2 asymptotes right here are going to shift to. So phase shift is the same as the start. That's kind of like with sine and cosine. Start and end, we're figuring out where these 2 asymptotes right here get moved to. Okay, so let's write that out. What we got? What's our inside? Inside the parentheses equals 0, and inside equals pi. All right, what do we get here? We get 4x equals pi over 2. So x is pi over 8. And here we'll get 4x equals pi plus another pi over 2. So let's get a common denominator here. That guy would be 2 pi over 2. So that's 4x is 3 pi over 2, or x is 3 pi over 8. And then our scale, period over 4. That's the same for everybody. Our period was pi over 4. Over 4, that's pi over 16. So maybe we should make everybody 16s. That way everybody has the same denominator. Okay, and then just like with tangent, I think the best way to graph this is label first and then draw the graph. Okay, so let's put in these start and end. 2 pi over 16. And then here we'll use the scale and count up. This would be 3, 4, 5, and 6. That was start and end. Start and end are my asymptotes. Halfway through is going to be the intercept. So look how we've got asymptote, skip a spot, intercept, skip a spot, asymptote. And the graph goes down instead of up. Let me try to draw him nice and pretty here. Okay, let's keep counting. Okay, so I shrunk my graph down so I can fit a little more on here. Okay, so we're counting by pi over 16s, and every 4 of them we're going to hit another asymptote. So here's 1 pi over 16, 0, that would be the y-axis, -1, -2. So here's my next asymptote. Remember, you always want some positives and some negatives. So I want to definitely go past 0. So look at this section in here. Notice how I've got 3 spots in the middle here. See, it goes asymptote, spot, 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 asymptote. I'm going to graph, and we're going to cross at the middle one. And that really should look like this. It's kind of drawn like, woo. Maybe, in fact, I should draw that a little prettier. I don't expect you to be an artist, so yours doesn't have to be perfect, but I should at least try to get mine looking a little better. There, that's a little better. And here, let's keep going this way. So 1, 2, 3, 4. Here's the next asymptote. And let's label them. We got 7, 8, 9, 10. And we're going to cross at the middle one. Oh, that was terrible. I can definitely do better than that. It's hard drawing with this drawing tool I'm using. That was even worse. Okay, good enough. Okay, last thing we're going to put on is the amplitude. Amplitude is the height at any of these middle spots. I could pick this spot right here. Look right there. I could pick this negative spot or this spot right there. This one here. Just any of them. So here, I'll pick this guy right there. That height right there is my amplitude. And I forgot what I had. 7. And this here, we might as well put that on. That low spot right there is at -7. And we're done. And that's a good place to stop.